Hello everyone. This video is on the Knewton Alta assignment for section 2.7, part 3, called Solving Linear Inequalities. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same and the structure is similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, in the assignment page, you should be seeing the title, the mastery bar, telling you how far along you've gotten, the objectives. It looks like there are 3 objectives for this particular assignment. And then under the current objective, there should be a question related to that objective. And at the bottom of every question, you should be seeing a feedback button in which you can, send feedback to Knewton if you wish. You will not have this instructor cheat button, This will not be there. But you will have a more instruction button. If you're struggling with a topic, click on this and you'll be taken to a page with some reading or some videos or both that you can study. And you'll be given problems that are related to the instruction, and completing those problems is another way to get through the assignment. Alright, so the first objective I'm looking at here is translate an English sentence into an inequality and solve. Alright, so I'll actually write this sentence out on paper, and we'll talk about the translation part. Now the sentence we're given is 23 greater than. Now be careful. Alright, 23 greater than B. This is the words greater than, not is greater than. Right. There's a huge difference. Greater than by itself means you're doing addition. Right, this means 23, more than B, greater than B, B plus 23. So that's what this expression means. B plus 23, that's 23 more than, 23 greater than B. Versus, is greater than. Is greater than means less than, greater than the greater than symbol. The is greater than symbol. Because the verb, right? It's just like the equal sign, earlier in chapter 2 when we were translating sentences into equations. Verbs, is, was, were, those will be where the symbols go, the equal signs, the greater than symbol, less than symbol. Right? There's a verb. Right? That makes a huge difference. So be very careful. So we have 23 greater than B, which is B plus 23. Is, there's the verb, at least. Now putting these together makes our inequality symbol. But you got the verb involved, right? Is at least. Now at least means greater than or equal to. You're this much or more, right? At least this. You're this much or more. That's what it means to be at least. Negative 276 is obviously just going to be the number negative 276. So we have this inequality to solve. B plus 23. Alright, this is 23 greater than B. Sorry about the compactness of the 23 there. I didn't leave enough space. Is greater than or equal to, that's the is at least, negative 276. And then we solve this. Now you can very easily solve this in one step. Solve for B right? Just by subtracting 23 from both sides. And hopefully you recall section 2.7 part 2, where we talked about all the properties of inequality. When you add or subtract the same number to both sides, the inequality symbol will not change, right? So the left side will be b, and this inequality will still be is at least or is greater than or equal to. And then over here we're negative 276 minus 23 would be negative 299. And there you go. All right, there's a description of the solutions of this statement, of this inequality. B can be any number greater than negative 299 or equal to negative 299. And that would be all the numbers from negative 299 to infinity, right? Including negative 299. And then you always have parentheses on infinity, right? I'm hoping, again, from earlier videos, right, section 2.7 part 1, you remember how to get to interval notation to describe your solutions. Now, I'm not going to make, that's not what this video is about. I'm assuming you know how to do that. And that's what they want. They want the solutions, the values I can replace b with to make this true. I want that in interval notation. So left bracket, negative 299, comma, infinity. This is all the numbers greater than or equal to negative 299, and then always parentheses on infinities. Right. And then after you submit an answer, it's going to tell you if you're right or wrong. Then it's going to give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. So we're skipping to this other objective. Just solve an inequality that requires simplification. Alright, so this is just, I said this in section 2.7 part 2 as well. Solving these linear inequalities is you go through the exact same steps that you would to solve an equation, a linear equation. You just have to pay a little more attention to what direction the symbol should be in. Alright, now I'll just recap the properties. If you switch the sides, you got to flip the symbol. When you add or subtract, the symbol does not change. When you multiply or divide both sides by a positive number, right, the same positive number, the symbol does not change. It's when you multiply or divide both sides by the same negative number, that's when you flip the symbol. Alright, so that's really all you have to focus on. Again, on occasion you may want to switch the sides. Remember, you gotta flip the symbol then, but probably not going to happen too often. I'm going to take all the variable terms to the left side all the time here anyway, so I'm never going to really just do that switching of the sides. Alright, so I'll write this inequality out. We'll solve it. Solve for b. Again, same steps as equations, just focusing also on what direction the inequality symbol should be in. So we're starting off with 3b minus 5b on the left is greater than or equal to 4b plus 18 on the right. Remember, with equations, you simplified in the beginning and you simplified both sides as you went through after every single step you performed. So over here, I can combine these like terms. 3b minus 5b, that's negative 2b, is greater than or equal to 4b plus 18. And then, like I said earlier, I'm going to do everything so I'm going to take all the terms with the variable to the left side. So I already have negative 2b over there. So I'm going to subtract the 4b from the right side and do it to the left side as well. Now this is just subtraction. Addition and subtraction doesn't change the symbol. So this is negative 6b on the left still is greater than or equal to, right? I just did subtraction. And then over here on the right side, I only have positive 18. Right. Now to get b alone, I divide by negative 6. And here it is. This is where the change will happen. I am dividing both sides of an inequality by the same negative number. So the symbol will flip. The direction of the inequality will change in this case, only because I'm multiplying or dividing by a negative number. If I were dividing by a positive number, nothing would happen. Right? The symbol would not change, but I did divide by a negative number here. So now instead of is greater than or equal to, it becomes is less than or equal to. And then 18 divided by negative 6 is negative 3. And here we go. Right, there's a description of all the numbers I can replace b with to make the original inequality a true statement. I can replace b with any number less than negative 3 or negative 3 itself, right, or equal to negative 3. So the interval notation for that would be from negative infinity to negative 3, including negative 3, right? That's what they want, the interval notation for this. And again, you can draw a picture, draw a graph of it if you wish, but you don't really need to if you can already see what the interval is going to be. So from negative infinity, comma, up to negative 3, bracket on the negative 3. Right? Negative 3 would be a solution here. Great. All right, and please read through the answer explanations. All right, this one. Now we have seen these words before as well. Classify an inequality as conditional, an identity, or a contradiction. So I'm not going to write these out again. I talked about these in an earlier section of chapter 2. Right? A statement is conditional if it's only true under certain conditions for certain numbers. So, the inequality we just did. This would be an example of a conditional inequality. This statement is true only under this condition, right? Only when the value of b is less than or equal to negative 3. Otherwise, it's not true. Right? It's only true in certain conditions. An identity, right, just like with the equations, an identity is a statement that's true all the time. Right? It's a statement that's true for every value possible. Every real, in this case, it's going to be for every real number. You can plug in anything you want for the variable, and it will be true, no matter what. And a contradiction, again, talked about these before. A contradiction is a statement that's never true, no matter what you plug in for the variable. So no solution. So, certain solutions, everything's a solution, no solution. All right, so I'll write this out. We'll go through trying to solve it like normal and see what happens. All right, so this inequality here, we have on the left side 2/3 times g minus 1/2 times the quantity g minus 14. And then the right side you have is less than or equal to 1/6 times the quantity g plus 42. Alright, now I know before I would clear parentheses before clearing fractions, but because all the fractions are outside the parentheses, I'm going to clear the fractions. Alright, again, it depends on what you prefer, doesn't matter, but the least, remember how to clear fractions. Least common denominator is 6, there's 3, 2, and 6, the least common multiple is 6. So I'm going to multiply everything on both sides, every term, by positive 6. Now because that's positive, right, I'm multiplying both sides by a positive number, the inequality symbol does not change. It'll still be as less than or equal to. Now the right side's easy enough. There's only the one term. Just multiply by 6, you got g plus 4. It's the left side, you got to multiply the 2/3 g by 6, and then also this negative 1/2 times g minus 14 by 6, right, both terms. Now 3 goes into 6 twice. 2 times 2 is 4, so you have 4g there. And then half of 6 is 3, so you got minus 3 times still this quantity I didn't distribute yet. All right, minus 3 times g minus 14. Now I didn't need the parentheses over here because it was times 1. That's why I didn't write the parentheses over there. Times 1 doesn't mean anything. Alright, then we distribute the negative 3. You got 4g minus 3g plus 52. No, sorry, 42. 30 plus 12, 42. Is less than or equal to g plus 4. And then I'm just simplifying, right? This is g plus 42 is less than or equal to g plus 4. And then if I were to do the thing where I take everything with a g on one side, everything without a g on the other, if I subtract g from both sides, and even if I just do that, you'll see what happens. Right, g's are gone, g's are gone, and I'm left with this statement. 42 on the left is less than or equal to 4 on the right. This is clearly false. This is a contradiction. All right, 42 is not less than 4, it's not equal to 4. So this statement is false no matter what I plugged in for g. All right, so you could plug in anything you want for g, any number at all, any real number, and this would be a false statement. All right, contradiction, meaning the inequality has no solution whatsoever. All right, but this is all we're asked to say, that it's a contradiction, I've noticed after trying to solve it. Oh, what happened? I might have made a mistake then. Oh my, I did make a mistake. I wrote the problem wrong. I wrote the problem incorrectly. My apologies. See what they had, the quantity g plus 42. I wrote the quantity g plus 4. Oh my goodness. That should have been a 42, which would have made this a 42, which would have made this a 42, which would have made this a 42 and this a 42. And then this is a statement that is true all the time, isn't it? 42 is less than 42. That's not true, but the equal to part is. 42 equals 42. Eep. This is an identity. Well, you finally get to see what happens when I get something wrong. I should have paid more attention there. There's a good lesson for you. Pay attention to what you're writing out. So yeah, this would be an identity, meaning that all real numbers are solutions. You can plug in anything for g, right? Anything for g, and it would be true. Oh, I feel silly now. I apologize. Well, again, there's a lesson for you. And now, if you get something wrong, it's going to back the progress bar up and make you have to do a few more problems, maybe a problem or two more. So this video will be a little longer than it should have been. I apologize. My goodness. All right. So at least we got something out of that. The lesson there is make sure you're copying down the problems correctly. Yikes. Okay, well, moving on. Hopefully I don't do that again. All right, so back to the translate a sentence. All right, so here, 82 less than r. Now remember, this is not is less than r. This is less than r. So we have subtraction here. R minus 82. And then here is less than, the verb is less than. This is the is less than symbol. And then negative 164. Right. So 82 less than r. That would be r minus 82. That's 82 less than r. Is less than. Right, this had the verb attached. Is less than, and then the other side negative 164. And then I would just simply add 82 to both sides. Okay, now adding doesn't change the symbol, so we have r is less than negative 82. And that's it. And then in interval notation, right, this would be all the numbers less than but not equal to negative 82. So that'd be from negative infinity up to negative 82, but parentheses on negative 82, and you can make a graph if you want to. And let me just double checking that I wrote the problem out right this time. 82, yes. Oh my goodness. Again, I apologize very much for that problem earlier. Okay, so parentheses, negative infinity to negative 82. Parentheses on that as well, because negative 82 is not a solution. Great. All right. Next question. All right, so another one where we give this, now again, let me just make sure I copy it down correctly, and then we'll go about solving for A and write the solution in interval notation. All right, so we have on the left side 11A minus 4 times the quantity A plus 2 is less than or equal to, and then the other side is 8A plus 10, and again I'm nervous. I'm giving it a once over just to make sure I wrote everything down correctly, and I did this time. Good. Now we simplify the sides, right? So we have over here, I'll distribute the negative 4, get rid of parentheses here. We have 11A and then minus 4A minus 8 less than or equal to 8A plus 10. The 11A minus 4A makes 7A, so we have 7A minus 8 is less than or equal to 8A plus 10. And then I'll just do addition and subtraction here to get all the A's. I like having them on the left. Makes the inequality easier to read, the solutions easier to get. So I'm subtracting 8A, and then I'd be adding 8, right? Getting rid of this negative 8 on the left side here. Now that was just a bunch of addition and subtraction. So the inequality will not change. Still be as less than or equal to. Over here I have negative 1A. Over here I'll have 18. And now, I can multiply or divide both sides by negative 1. And that will flip the symbol, right? Multiplying, dividing by a negative number will flip the symbol. So now this is greater than or equal to. You got A on the left, negative 18 on the right. There's your solutions, right? A can be any number greater than negative 18 or negative 18 itself. So that'd be from negative 18 to positive infinity, including negative 18, right? So bracket on negative 18. And this is what we're asked to enter. And always parentheses on your infinities. So left bracket, negative 18, comma, infinity. And then close the parentheses, right? Put the parentheses there. Great. All right, so again, I made sure I copied the problem down correctly. I don't think I'll get over that for the rest of the problem. All right, so it bumped it up a little bit. It didn't put it up like as much. The progress didn't go up at like a quarter like it usually does, when you answer a problem. So that means I'm probably going to have to answer more, one more question than usual here. Okay, so classify as conditional, identity, contradiction. So once again, I'll write this inequality out, go through solving it with our usual steps, and see what happens. Do I get something that's only true under certain conditions, or never true, or always true? Right? So once again, let's make sure I'm copying this correctly. So the left side, we have 6 times d minus 3 times the quantity, 7d minus 1, and then is greater than or equal to. And on the right side, we have negative 3d minus 6 times the quantity, 2d minus 1. And again, double checking. Yes, that is copied down correctly. Let me simplify, do the distributive property, get rid of these parentheses. So on the left side, I have 6d, minus 21d plus 3 after distributing the negative 3. And then over here, I'm distributing this negative 6. We have negative 3d, and then minus 12d plus 6. So 6d minus 21d, that'd be negative 15d plus 3 on the left side, greater than or equal to negative 15d plus 6 on the right side. And then if I add 15d to both sides, you're going to see that I have 3 is greater than or equal to 6. Right. 3 on the left, 6 on the right. I just did adding and subtracting when I add the 15d, so the symbol won't change. And is 3 greater than 6 or equal to 6? No. So again, and I made sure I copied it down correctly this time. So this is for sure a contradiction. This will never be true, right? No matter what you plug in for d, this is false. Right? So this inequality has no solution whatsoever. Alright, but they do want us to just highlight the contradiction part. Alright, so this is a contradiction, and hooray, I did that one right and copied it down correctly. Alright, great. Alright, next, so another inequality that I'll write out and solve. I'm just making sure I copy it down correctly. So on the left side we have y, then minus 5 times the quantity, y plus 1 is greater than or equal to 2y minus 5. And here I'm distributing the negative 5 to clear the parentheses, so we have y minus 5y minus 5 is greater than or equal to 2y minus 5. This is negative 4y minus 5 is greater than or equal to 2y minus 5. And then I'd subtract 2y from both sides and add 5 to both sides to get all the terms with y on one side without y on the other. So I have negative 6y on the left is greater than or equal to 0 on the right. And then we're dividing both sides by negative 6, which will flip the symbol. Right? Because you're dividing by a negative number. So y is now, instead of greater than or equal to, y is less than or equal to, and then 0 divided by something that's not 0 is just 0 again. There's your solutions. All the numbers less than 0 or equal to 0. So in interval notation, that would be everything from negative infinity to 0, including 0. There's your interval notation for that set. So everything from negative infinity, comma, up to 0, and then a bracket on 0. Right? 0 is the solution to this inequality. Wonderful. Alright. Alright, so it looks like one more of these based on my progress. I'm just going to speak this one out. Left side, you have 13m. Then I would subtract 8m to get 5m on the left side. And then divide by positive 5. So you'd still have greater than or equal to. M is greater than or equal to. Now negative 15 divided by positive 5 would be negative 3. You'd have m is greater than or equal to negative 3. So all the numbers greater than negative 3 or equal to negative 3, so you have brackets negative 3 and then up to infinity, right? All the numbers greater than negative 3 are also solutions, and then parentheses on that. Wonderful. Alright. So that objective's done. All right, so back to translating. All right, now no less than. All right, is no less than means is not less than. Well, if you're not less than something, that means you're greater than or equal to it. So is no less than means greater than or equal to. Is greater than or equal to. So I have y minus 64 is greater than or equal to negative 128. Right, so that's the inequality I'm writing out here. So again, 64 less than y. So that's y minus 64. Is no less than means is greater than or equal to. That's is no less than, is not less than. Means is greater than or equal to. And then negative 128 on the other side. Then I would just simply add 64 to both sides, and we get y is greater than or equal to negative 64. Right. And in interval notation, the numbers greater than negative 64, right? Those are from negative 64 to positive infinity, or equal to, right? So you got a bracket on negative 64. Negative 64 is one of those numbers, and always parentheses on infinity, right? So there's your interval notation. So bracket negative 64, comma up to infinity, all the numbers greater than or equal to negative 64. All right. Okay. All right, so it looks like one more translation, and then we'll just have the conditional, identity, or contradiction problems. All right, so 72 greater than r. Remember, that's r plus 72. It's not is greater than. It's just 72 greater than. All right, so r plus 72, and then just straight up is less than. Just use the less than symbol, negative 432. So I'll just do this here. So 72 greater than r, right, r plus 72, is less than negative 432. And I would just be subtracting 72 from both sides. So r is less than, again, it's just subtraction, so the inequality doesn't change. And that'd be negative 504. Right. So r can be any number less than negative 504. So that's everything. If again, you always go low to high, left to right on the number line with your interval notation. That'd be everything from negative infinity up to negative 504, and then parentheses on both of those, because neither one of them is a solution to the inequality. All right, so parentheses, negative infinity, comma, up to negative 504, and then close the parentheses. Right? 504 is not a solution, negative 504. Great. All right, so now finally we're getting to those, back to those, is it a contradiction, a conditional, or identity? All right, so here we'd have negative 3y minus 6. Over here, this would be negative 9y plus 6y, negative 3y again, but then plus 2. So you can get rid of the negative 3y's by adding 3y to both sides. And then basically you have negative 6 is less than 2, and that's true all the time. This is an identity. This should be true no matter, you end up with, if you tried solving, you'd end up with negative 6 is less than 2, which is going to be true. That is a true statement, and it's true no matter what you plug in for y. So all real numbers are solutions. This is an identity. All right. Great. Moving on. All right. Now this one's got some fractions in it. I'll actually write this one out. And again, hopefully I write it out correctly. Haha. So we have c divided by 4. Plus c divided by 10 is greater than or equal to 7c divided by 20 minus a half. I'm hoping it's obvious here that the least common denominator is 20. So I'm going to multiply everything on both sides by 20. Now that's a positive 20, so the inequality doesn't change. And after distributing, This would be 5c plus 2c, right? 10 goes into 20 twice. And over here I'd have 7c, right? 20 and 20 cancel. You'd have 7c minus, and then half of 20 is 10. So we have 7c on the left is greater than or equal to 7c minus 10. Subtracting 7c from both sides gives me this inequality. 0 is greater than or equal to negative 10. This is always true. So once again, we have an identity. All right, this is true no matter what you plug in for c. You'll always end up with a true statement. All real numbers are solutions here. Great. And I think that should be it. Yeah. Alright, so that's it for this preview version. Again, I do apologize for that one problem where I miswrote the problem. But the way I went about even solving the miswritten problem was correct. You know, just I had the problem written out wrong. The steps were good. So I'm hoping that watching, again, this, hoping watching me here helps you out in some way when you work on the assignment yourself. All right, just the questions here weren't the same as the ones you're going to see, but the objectives are the same, the structure is the same. So yeah, so I'm just hoping this all helps when you work on the assignment on your own. And thank you very much for watching.